would like to say that the work is done by my master student Abed under my supervision. What motivated this work is actually the explosion that happened in Beirut 3 years ago. So that's what really motivated that. I was part of the assessment team that was on the ground, which took a lot of time, and it wasn't as efficient at the beginning. So we tried to come up with this idea, and with the hope to implement it at some point. So the topic is about a virtual training game for post-earthquake damage inspection. So the outline of my presentation, I will go over the background, gaps and contribution, objective, the game design, how we designed it, the testing and results, and then I'll conclude at the end. So we all know that earthquakes are one of the most devastating natural hazards that cause great damages. Earthquake can cause huge damages to the structure and non-structural members of a building. The assessment of structures after a damaging earthquake is a challenging task. So typically the norm is to carry out visual inspections, but this is really time-consuming, and if practitioners or inspectors did not go over a certain training, then the inspection won't go as expected. So rapid visual inspections can save time and money, but require proper training and qualification. And that's where our work comes into play. So it's about like really getting a great training tool. Oops, sorry. Yeah. Okay, so accordingly, actions must be taken to solve the following: lack of training and qualifications, subjectivity in decision-making, because when inspectors go out on the site, there's some subjective measure here, tendency to overestimate or underestimate the observed damage level, because not all inspectors have the same approach to assessing the damages, unless they're well-trained. Therefore, an effective inspection training system is required. Now, there are 3 different approaches for training: the traditional, the hands-on training, like one-on-one with inspectors, and then the gamification technique. As you can see from this tabular representation, the gamification part, and by the way, gaming is one part of gamification, because there are so many ways or approaches under gamification. Gaming is one of them. And as you can see here, it hits on so many features, from high engagement, engaging of the user, cost effectiveness, and learning pace. So it has a lot of advantages. So that's how we decided to come up with a gaming tool. Why? Because the purpose of serious games is twofold: to be fun and entertaining, to be educational, okay? And game-based learning improve the training activities and encourage people to learn and acquire knowledge. However, there are some existing limitations. Many research papers studied the use of serious games for inspection training purposes, but none focus on earthquake damage inspection. A lot of games have been done out there, but none has really studied the post-earthquake evaluation and assessment of buildings. So serious games in this case can train engineers on performing better visual inspections without having to be present in the inspection area. And I would like to mention here, we're not talking about inspecting on real site. The goal of this research is to help people train visually and digitally outside the inspection area, so they are well trained to do that on site, okay? Because sometimes there's a misconception about like really doing that or like practicing all of that on the site, while we're doing that in a room where we're trying to train those inspectors. So by the time they go to the damage area, they are ready and well trained. Serious games allow users to improve their training skills through engagement, motivation, role-playing, and repeatability. Okay, I'll try. Okay. So what's the objective here? It's to overcome the limitations of visual inspection, especially when it comes to the subjectivity measure, because again, not everyone assesses the same way, and automate post-earthquake safety evaluation training of, in particular, reinforced concrete buildings. So that was the focus. Using gaming technologies or serious games. Here's our framework. So we use the Unity game engine to create our game. So the elements, as I mentioned, it's a reinforced concrete building, so the structural elements are the columns, shear walls, beams, slabs. The non-structural elements are stairs, infill walls, parapet walls, etc. And then, what is it made of? So we have the scene modeling, and we have to design all the structural and non-structural elements. Then we have to design the damage, right? Because after all, we're going to train those inspectors on assessing the damage. So we need to add that damage aspect to this scene. And finally, the big part of that game is actually what we call the earthquake damage inspector, which is composed of two main parts: the training tool and the assessment tool. So in the first part, we try to train those people, and then once we're sure they're trained, we ask them, okay, now we have to assess you. Play it alone. We're not going to help you in that. We want to make sure that you're well trained. So that's the second part, which is the assessment tool. And in this case here, we designed within the game environment 20 different buildings of various damage levels. Okay, so we can really try to well assess those inspectors. Moving on. So that's part of the scene model here. As you can see, that's a building made of a ground floor, 4 stories, and the roof. Okay, that's a sample interior picture here. Okay, we have 4 damage severities here: D1, D2, D3, D4. As you can see here, that's the worst one. Okay, so that's the severe damage level. Now, that's the last part of our framework, which is the training and the assessment tool. So the inspectors will click on the training, finish the training practice or small game, and then he or she will move to the assessment part. Okay, so here, in the first scene, the user is asked to explore the building by clicking on all the structural and non-structural components. So again, this training part, we're helping the inspectors. We're trying to guide them through this game. They don't have to guess anything. They have to click and read and get to learn everything. That's the whole part of this training part, this training tool, okay? So in the remaining scenes here, like that's one sample scene, the user must click on damage component to learn more about the type of damage and severity. So once the user or inspectors has gone over this whole training tool, now they're ready to go over the assessment tool and then assess 20 different buildings. So that's the assessment tool. Again, as I mentioned earlier on, there are 20 different buildings of various severity levels, and then they'll have to assess that and fill out inspection forms. Okay, they'll have to fill out inspection forms, and then depending on the scores of these inspectors, then we'll ask them to go out on the site. Otherwise, they have to go over this game and then get this training back again because they're not ready yet. Okay, as part of this framework, we had a questionnaire survey where we asked a lot of questions just to get a feedback about this, because that's the first game that's done for post-earthquake damage inspection. So we wanted to acquire their feedback and try to check whether they liked it or not, whether it's feasible, whether it's beneficial or not. So 30 civil engineers took part in this survey. Unfortunately, in Lebanon, we asked around maybe 200 people, only 30 replied. So that's one of the limitations of this study. We're currently targeting to reach more people as part of a bigger study. The age of the participants vary from 20 to 40 years old. They occupy different job positions. And the data collection is automated, so we gather everything right away and then we get the results. So we don't have to really post-process anything. So here's some visual representation of the background information about the participants. This is like some sample survey results, and then the results here. So as you can see, based on the results, if you take a look at all the different pies, the results actually reflect the advantages, the great advantages of using games and assessing damages. Okay, so the participants or inspectors, which are practitioners, and the first one here, around 70% mentioned that they learned about the types of earthquake structure and non-structural damage throughout this game. It was beneficial to them. They learned about the damage severity of components because they had to assess 20 different buildings of various damages. They were able to classify buildings into different safety conditions around like completely agree and agree that's around 80%. Okay, and then it increased their overall knowledge in post-earthquake damage inspection. That's around 60%. Okay, so based on the result, it shows that game engines are really a promising avenue towards assessing and evaluating post-earthquake damages. Okay, they also enjoyed the game. Around 60% enjoyed the game. They mentioned that the game is easy to use. And the user interface is kind of like around 60% agreed it's clear and straightforward. Okay, other questions were asked as well, and like for example this one here, game-based learning is better than traditional method for training purposes. I remember some of them saying, can we keep on playing? We like this game, it's really nice, we don't get to do that often, so it was a nice experience. So. Okay, in a conclusion, we designed a serious game to train practitioners. Results revealed the importance of adopting such an approach in order to assess post-earthquake damages, and it proved as a promising avenue towards better training and learning performances. Definitely there are some limitations. So there's a scarce number of previous studies that were available when investigating the topic. We couldn't find a lot of studies on a game done especially for that purpose. It was hard to get access to the various reports in the region and elsewhere just to gather the information. And because these reports, we relied on these reports and forms to be able to build the games. What makes this as a severe level damage? Because we had to rely on a lot of documents to do that. The study of ground and soil conditions was not included, so we're currently working on that actually. So in the new game, we're taking that into consideration. But in this study that I'm presenting now, we did not include it. And definitely, as I mentioned earlier on, the sample size is limited, so we're targeting more people. So we're going to try to address those limitations in the future. And that's part of our future work. So before I conclude, I just want to show you quick short videos here. So these are like some quick representations of the game. That's the earthquake damage inspector. Here again, as you remember, the training part is where the user gets to click and learn. So everything is provided to the user here. Okay, door, non-structural. These are the non-structural members. This is the simple example. Next scene. And then that's how they get to learn that. Okay, let me move on to this one. Here where it's the assessment part, they're trying to fill out the inspection forms, right? After they got trained, so they need to familiarize themselves with these scenes in the training part so that they can assess them well in the next part. Okay, thank you.